We're going to go ahead and discuss the following: domains and ranges of radical, rational, logarithmic, and exponential functions. Objective. The objective is find the domain and range of radical functions, rational functions, exponential functions, logarithmic functions, logarithmic versus exponential functions. Let's start with the radical functions, the odd roots case. Assume we have the function y equal to the b's root of x to the power a minus c. If b is greater than 0 and an odd number, the domain will be from negative infinity to infinity, and the range will be from negative infinity to infinity. Let's take a look at the example. Let's find the domain and range for f of x equal to the cubic root of 3x cubed minus 12. Since, number one, the input to f of x can be any real number, and the cubic root of any real number is a unique real number, it follows that the domain is a set of real numbers from negative infinity to infinity, and the range is the set of real numbers from negative infinity to infinity. Next, we will handle the radical functions, the even root case. For example, let's suppose that y is equal to the dth root of x to the power a minus c. If d is greater than 0 and an even number, the domain is the set of values for x that results in y greater than 0, and the range can be determined from the domain. For example, let us find the domain for the square root of 3x squared minus 12. Steps for the even case. First, let 3x squared minus 12 be greater or equal to 0. Why? Because we do not allow under the square root any negative value. That's why we equate whatever under the square root, we set it as greater or equal to 0, and then we have to solve for x and figure out the x's that will result in a negative value under the root, and we exclude them from the domain. The second step is to take the negative 12 on the right hand side. So we will have 3x squared greater or equal to 12. Thus, if we divide both sides by 3, we'll get x squared greater or equal to 4. This implies that x is greater or equal to 2 and x is less than or equal to negative 2. Two branches. So the domain for the branch x greater or equal to 2 will be from 2 to infinity, because x greater or equal to 2, that means x could go 2, 3, 4, 5 until infinity. So the domain will be from 2 including 2. This square bracket means including 2 all the way until infinity. The parentheses mean it's not including infinity. And for the branch for x less than or equal to negative 2, its domain will be from negative infinity, not including negative infinity, all the way until negative 2 including negative 2. Therefore, the domain of f of x will be the set of real numbers, but we're going to take away from it 2 and negative 2. So we will start from negative infinity, and then we go all the way until negative 2, including negative 2. And then the union of positive 2, including positive 2, all the way until infinity. Question. The range is from 0, where 0 is included, all the way until infinity. Why? The answer to that is as follows. The range is the value that we're going to get from the square root. And the values that we're going to get from the square root cannot be negative. But the lowest value can be 0, because square root of 0 is 0. So the lowest value is 0. And the upper or the highest values, sky is the limit. Could go any positive value. So that's why the range will be from 0, including 0, to infinity. Next, we will handle the rational functions. Let y be equal to ax to the power n plus bx to the power m divided by cx to the power p minus d multiplied by x. Since we have an equation on the numerator and an equation in the denominator, we want to make sure that the denominator will not be equal to 0. So we figure out the values for x that will make the denominator equal to 0 and exclude them. So to that end, we have to solve the equation on the denominator, which is cx to the power p minus dx equal to 0, and then we solve this equation. And we have to exclude the values of x that result in the denominator equals 0. We have to exclude them from the set of real numbers. To find the domain of y equal to 2x squared plus 3x divided by 5x squared minus 20x, the steps are as follows. Let 5x squared minus 20x be equal to 0. If we divide by 5, we will get x squared minus 4x equal to 0. If we take x as a factor, then we will have x multiplied by x minus 4 equal to 0. From this equation, we can deduce that the values of x to be excluded are x equals 0, because if we plug in 0 outside, the equation will give us 0. So x equal to 0, and the second value is x equal to 4. So if we plug in 4 outside and 4 inside, then the parentheses will give us 4 minus 4, which is equal to 0, will give us the result equal to 0. That means the two values that we have to exclude them are x equal to 0 and x equal to 4. So consequently, the domain will be from negative infinity to 0, not including 0, union from 0 not including 0 to 4 not including 4, union from 4 not including 4 to infinity, obviously not including infinity. The question is the range. What is the range? And the answer is we did not go through the asymptotes, so we will not be able to determine the range now. We'll postpone that until we cover the asymptotes. Logarithmic functions. The function y equal to log of ax minus c y equal to log ax minus c. To find the domain for this, first we have to solve the equation ax minus c equals 0, and then find out the values of x that result in this left hand side equals 0, because log does not allow 0 values or negative values. So we have to figure out the values of x that result in ax minus c equal to 0 and exclude these values from the default domain, which is 0, infinity. However, the range is going to be from minus infinity to infinity. Let's take a look at an example. For y equal to log of 2x plus 8, the steps are as follows. Set 2x plus 8 equal to 0. Move x to the right hand side, so it will be 2x equal to negative 8. Divide each side by 2, so that implies x equals to negative 4. The domain will then be from negative 4, not including negative 4, all the way until plus infinity. Since the domain includes real numbers greater than negative 4, and when the value of x approaches negative 4 from the right, y approaches negative infinity, and as the value of x increases towards infinity, y approaches plus infinity. From 6 and 7, the range of y will be from negative infinity to positive infinity. It's time now for us to go ahead and compare between two functions, the exponential function and the logarithmic function. Let us take a look at the function y equal to log to the base c of x when c is greater than 1. Since x cannot be 0 or less, x cannot be 0 or less. Why? Because the log only receives real numbers that are greater than 0. So 0 is not allowed and negative real numbers are not allowed. Since, one more time, log only receives greater than 0 real numbers. So if that is the case, then its domain should be greater than 0 to infinity, because greater than 0, positive numbers, positive real numbers. That's what this log will take. Greater than 0, positive real numbers only. It will not take negative. So the greater than 0, positive real numbers, they start from a little bit more than 0 and they head to infinity. That's the domain of the log. Let's take a look at, however, the range rises from negative infinity to infinity as x increases from 0 to infinity. This point will be clear when we get to the graph. So let's take a look at the graph. The graph of g of x represents a log function with base 2, with base c equals to 2. Here is the graph. Let's take a look at this graph. Let's watch if we are sliding down along the path of the graph. So the graph, we're going down. What happens to x? X is decreasing. X is going towards 0, but y is decreasing also. Y is decreasing, x is decreasing but continue to be positive, y is now negative and decreasing. Both of them are decreasing, x trying to get to 0 and y is headed towards infinity while x is trying to get to 0. Since x will never reach 0, then y will continue until close to infinity and x will not reach 0. So when x heads towards 0, y is heading towards negative infinity. We can summarize that by limit. So we're assuming limit y as x approaches 0. X approaches 0 by sliding down. So limit y as x approaches 0 is equal to negative infinity. Now let's take a look at if we reverse our direction. If we want to go upwards, going upwards, while x increases, y increases. If x head towards infinity, y will also head towards infinity. So that's why the limit of y as x head towards infinity is equal to infinity. Now that we said this, let's go ahead and look at the second graph. The graph of y equal to f of x equal to 2 to the power x represents an exponential function with base c equals to 2. F of x equal to 2 to the power x, and the base is 2. The base c is 2. By the same token, if we're sliding from the top, the value of y is decreasing and the value of x is decreasing. We're sliding. The value of y is decreasing. The value of x is decreasing. Y cannot get to 0, while x is continuously decreasing and x will be heading to negative infinity before y gets to 0. So we can summarize that limit of y as x heads to negative infinity is 0, because y is getting smaller, it cannot cross the x-axis but continues to get smaller, approaching 0. So limit as x heads towards negative infinity, limit of y as x gets heading towards negative infinity will be equal to 0. One more time, limit of y as x approaches negative infinity is 0. So we can see that this is this limit. Let's take a look at the limit if we climb up on the same graph of f of x. If we do so, then we're saying as x approaches infinity, y will also approach infinity. So we can summarize it as limit of y when x approaches infinity is equal to infinity. Now we can see the brown. The brown is on the positive side of x. It's not on the negative side. On the positive side of x. And the blue is on the positive side of y. On the positive side of y, the blue. We said all the x is for the domain. So if the brown is on the positive side of x, that means it represents the domain of x. And over here we said f of x, which is the blue, is only occupying the positive side of y. Since it's occupying the positive side of y only, then it is equal to what? Equal to the positive side of x. But the positive side of x is the domain of g of x, and the positive side of y is the range of f of x. So let's take a look at the comparison. The domain of g of x is the range of f of x. Let's say the domain of g of x. We said the domain of g of x is what? The domain of g of x is all the positive values of x that are greater than 0. So the domain of g of x is from 0 to infinity. So we said the domain of g of x should equal to the range of f of x. One more time, domain of g of x, we just said it's from 0 to infinity. So the range of f of x must be from 0 to infinity. Look at the range. The range is how much of the y-axis the curve of f of x occupies. It occupies from 0 to infinity. So it's the same. The domain of g of x is actually the range of y of x. The domain of g of x is the range of f of x. Here, summary. Y values of g of x. Look at the function g of x and look at its y values. The function g of x, its y values are from negative infinity to infinity. The y values of the brown from negative infinity to negative infinity. So the y values of g of x are the x values of f of x. Let's take a look at the x values of f of x. F of x here is in the dark blue. X values of f of x from x going to negative infinity all the way x going to infinity. So we can see that these values are equal. The y values of g of x. Look at the y values of g of x. Let's use the pen and let's do some coloring so that it will be a little bit more clearer. Let's use the pen. Let's take a look at the y values of g of x. We said the y values of g of x are these. This is the y value of g of x right here, from negative infinity to negative infinity. The y values of g of x, we said, equal to the x values of g of y. Is the x values of f of x. What are the f of x right here? X values of f of x. Aren't they the same? Negative infinity to infinity, negative infinity to infinity. So they are the same. Let's take a look at the second point. The range of g of x is the domain of f of x. Let's take a look at what we should examine. The x values of g of y. Let's take a look at the x values of g of y, g of x. The x values of g of x. G of x is the brown. The x values are these. So the x value is here 0 and the other x value is infinity. So 0 to infinity. The x values of g of x are the y values of f of x. Let's take a look at the y values of f of x. The y values of f of x are these. From negative infinity, from 0 to infinity. From 0 to infinity. Here, the x values in this crooked line from 0 to infinity. And here, the y values from 0 to infinity. So here is the point. They share this point. The y values and x values, y values always represent the range. X values always represent the domain. So it's very clear that the domain of one of them is the range of the other one and vice versa. What's next for us is we have to prove that f of x is the inverse of g of x. That means we have to prove that of the logarithmic. That's what we need to prove. Exponential is the inverse of the logarithmic. To prove that log function is the inverse of exponential function, the base for both of them must be the same. Let's take a look at the function f of x. Assume that f of x is equal to log to the base c of x. And assume g of x to be equal to So g of x is equal to c raised to the power x. We need to show the following to prove that they are inverse of one another. We need to show that f of g of x is equal to x. That means whatever g of x did on x, f is going to come and undo it, and we get x back. Let's take a look at how we approach it. Without loss of generality, let's assume that c is equal to 2 and x is equal to 3. So if we take c equal to 2 and x equal to 3, we're going to replace every c by 2 and every x by 3. So let's take a look at what we have here. Therefore, if we want to get what? F of g of x, we know that g of x is equal to c to the power x. Since c to the power x is equal to g of x, then we want what? We want log of g of x. Here is g of x. So we have to plug in, instead of g of x, f of c to the power x. And that's what we did over here. This is f of c to the power x, where f is equal to the logarithmic. F itself is equal to logarithmic. So we have log to the base c of c to the power x. One more time, c to the power x is g of x. So we're getting f is log of x. So we're getting f of the inside g of x. That's what we want. So since we have this, we said we want to replace c by 2 and x by 3. So this is equal to, and we did the replacement, replacing c by 2 by 3. If we look into this, log to the base 2 of 2 to the power 3, 2 to the power 3 is equal to 8. So we could just move over here and plug in 8. So this is log to the base 2 of 8. But we know log to the base 2 of 8 is equal to 3. So this will end up giving us 3. The result is 3. But 3 is x equal to 3. So 3 is equal to x. So we started from the left. We did log of c to the power x. But c to the power x is g of x. So as if we started from log of g of x, and then we ended up with x over here. This is equivalent to this. This is equal to this. So we started from log of g of x and we ended up with x. So that is the inverse of this function. The proof is achieved for case c equal to 2 and x equal to 3. Changing the values of c and x will lead to the same conclusion, the same result. It then follows that f of x is indeed the inverse of g of x and vice versa. That's it. I hope you enjoyed it. You have a good day.